This is section 1.5, page 26, number 19. And what we have to do is we have to first determine how many segments can be drawn through the points in each of the figures. And no 3 points are collinear. So we start with 1 point and draw 2 segments. Start with the next point, 2 segments. Last point, 2 segments. So with 3 points, I have only 3 unique segments, and that's key. Now I started with 4. Okay, and I pick 1 point and I draw all the possible segments. Now the next point, draw all possible segments. Notice how I'm doubling up on some of them. That's going to be key. Next point, draw all possible segments again where I have some where I'm doubling up. Last one. So now we have 4 points, but how many unique segments do we have? We have 6 unique segments. Now let's look at 5 points. 5 points. 1, 2, 3, 4. 5, 6, 7. 8, 9. 10. So I didn't draw in the doubling up in this one. Okay, so I'm just highlighting the unique ones. So we have 5 points, and we have 10 unique segments. 1, 2, 3, 4, 5. Now this is with 6 points, so I have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and lastly 15. So with 6 points, we have 15 segments. Now in the next part, part E, they want us to make a drawing, they want us to predict. So let's look at a prediction. And again, this is very similar to one that we've done in a previous section. Let's look at the common difference between the number of segments. Our first common difference is 3. And we have a common difference of 4, then a difference of 5. So notice how with each, when I add 1 more point, okay, the number of segments that you would add goes up by 1. So lastly, we would have 6. So now when we have 7 points, we would have a total of 21 points. I'm sorry, 21 segments. I'm mixing those two up. Now the last part is asking how many segments can be drawn with n points. So n number of points. We have n number of possible points. Since a point can't be paired with itself, we have n minus 1 possibilities to make a point. Now we divide by 2 because we have to keep in mind duplicates that we have.